hello, thank you for coming. And I don't know if anybody is actually a Postgres user here. How many of you? Yay! So I got to all the Postgres people. That's good. I haven't been to this conference before, and it's like for me, I don't know the audience well. I see the program is mainly like search and AI, and I was like, who will come to a Postgres talk? But I get some people, so thank you. So today we will talk about the anatomy of table-level logs. But who am I? I am working in a startup called Zeta, and we have some open source projects that I'm managing, and I'm like working with Postgres over 13 years. So I'm properly I don't know much besides Postgres anymore because I really am focused on Postgres for a long time. And I am also active. I became a contributor recently this year. And I'm also quite active in the local communities. I organize a Postgres meetup in Prague. I live there. And also in Turkey, which I am from. So yeah, that's me. And I love Berlin. I haven't come to this conference before, but I like visiting because I have some friends here and some other conferences that I visit. And I have a daughter. She will turn 6 this weekend. So that is her. She likes hugging. And agenda. So first we will talk about the concept of MVCC in the Postgres sense. And we will talk about EDL locking and how the Postgres log queue works and how we can actually reduce the log contention. And I will introduce you at the last 5 or 10 minutes of the talk will be about this open source tool that we are working on called pgrole for schema migrations. Okay, so why I chose this topic? First, I wanted to basically think about when I said, okay, this tool is trying to reduce the logs when I joined Zeta, so I need to maybe explain a bit of how Postgres handles locking internally. And then, but before I started, I was like, okay, locking. So I bought lots of books as an excuse to understand locking in different senses about log picking, Persian logs, history of logs or something. And what I learned, I mean, not necessarily is related to Postgres' log, because in real life or the physical world, logs are about security, securing, I don't know, a door or a bank or anything like that. But in Postgres, it's nothing like security. So locking in Postgres is about concurrency, how one operation can do its thing while necessarily not blocking the other thing if they are sharing the same resource. So it is a primitive for concurrency and nothing about security. But what is kind of related to what all these books that I read is to be able to pick a log, you need to understand how its tumblers and pins and mechanism work. And to be able to understand the locking in Postgres, you have to understand the internals, especially the concurrency-related internals. And that's why we will talk about MVCC a little bit. So the way that Postgres handles concurrency, we have this MVCC, as I mentioned. It means multi-version concurrency control. What is it actually? That thing is to be able to make Postgres highly efficient for DML operations, we have this architecture. So instead of modifying the data that is being modified basically in place, we just create a new version, a new copies each time whenever it's transaction updating this data, let's say. And this way, a reading this version, a writing that version, they don't block each other, so they can actually do their own thing. This allows Postgres to have reads and writes, mixed workloads, and we are avoiding taking excessive locking. So if we have this versioning system, we don't necessarily lock for DML operations, for example. But still, even though reads may not block writes, but they will still acquire lightweight locks on the objects like tables and views and rows. So we cannot avoid altogether all locking, but most of the issues that comes with, thanks to the MVCC, we sort a lot of the locking itself already. And we will talk about it later, basically, how we do it. But so far, I only said theoretical things, but this is a simple example. I think it's quite easy to follow. And I wanted to show how it actually works within an example. So as I said, when a transaction updating data, Postgres is creating a new version of the row while keeping the old row version still there. But then there are some system columns that are not visible to the users, but they are important for this system. So there are many, xmin, xmax, cmin, ctid, and so on. But for us, for this example, we just need to know 2. One is xmin, that is the transaction ID that creates this version that we are looking. And the xmax is the transaction ID that deletes or updates, basically modifies that version. And if it's null, it's the current one. So in this example, let's see what I created here. So there is a single row exists with Alice's salary at 50,000. And then first transaction, transaction ID 100, it's starting. It gets a snapshot for the select, and it sees the salary at 50,000. And there, the xmax is null. Basically, this is the current one. And then the rows xmin, that is like the version that actually created this, is 99. So it means that it's already created by another previous transaction. It is less than our transaction number. In this case, it's 100. So it's already committed. So that's why we see it in this select snapshot. And then the second transaction ID, this is the transaction ID 101. It is updating the salary to 60,000. But again, instead of doing it in place, it creates this new version. And while it's creating the new version, it is the creation one, the xmin. So that is the keeping the new transaction ID 101. That's kind of showing that which one actually updated this. And it is now marking the old one with xmax 101. So basically, that is the one that is updates it, and the new version created with xmin with the one that it actually does the update. So then, when the second transaction actually commits, any new snapshots will see this version. But the versions, the old version, if there's some select, let's say, using this version, it will still keep going. And then, let's see if I run the select again before the transaction to actually commits, and I still see the salary 50,000. Why? Because we didn't committed the 101 yet. And then, when the commit happens, when I third time do the select again, then I will get a new fresh snapshot, and that will be seen now 60,000. The behavior that I describe here is not like in every transaction level of Postgres. This is we have different transaction levels, and this is the default behavior if you didn't change anything, and that is read committed transaction isolation level. So we have from read uncommitted to read like serializable level, but the way that I'm describing is the behavior of basically default behavior of Postgres. And yeah, so basically this is how it works. But I didn't want to basically like say, okay, MVCC is perfect and it doesn't come with any implications. I just wanted to add like, it's clear things that are like maybe, needs to be taught about it. When we keep these multiple versions of rows, we actually accumulate them, right? So until it gets cleaned by a vacuum process, they will just keep piling. And basically, it has implication on the size as well. So temporarily, this database size can actually grow. That's why it's really important the auto vacuum settings that you are setting in PostgreSQL needs to be basically tuned based on your system. And also, another thing to probably take it that long running any transaction is not so great idea. So hopefully your transactions don't run too long. And yeah, otherwise we actually basically sorted lots of stuff thanks to this approach. Okay. So why actually we lock? Because like whatever lock we do, doesn't matter the type, it will always reduce the throughput, it will potentially increase the latency, and it basically means loss of performance. So why actually we are doing this? The intention is that we are trying to make sure the data doesn't have corruption, we don't get concurrency anomalies, so we have to get the correct results at the correct time of the query. That's why we have to have an agreement. That's why we have the transaction isolation levels. And that's why we have to take some time to make things correctly before just providing, throwing out the data without considering any of this. So I just wanted to make a simple note that this is actually needed. We have to accept this cost. And today, we will mainly talk about the DDLs itself. Why? Because usually the other operations, like the MLs and so on, they don't really require strong locks, but DDL operations like alter table, vacuum full, for them, we really have to have stronger locks. And that means that we'll probably block other DDLs, other DMLs, and selects too. So we have to understand how we can reduce this DDL locks impacts. That's why we need to understand how they work, basically. Okay, I also divided the talk with 6 or 7 takeaways. So if you don't take anything from the talk, just take this with you, and I hope it will be helpful. So first thing from up until this point is that MVCC will really help you with writes blocking reads, but not object locks taken by DDL. So we have to really understand it. And another maybe nuanced topic is that one statement taking one DDL lock will not be always the same, even the same statement with different subcomments. So you will have to understand each of the statements' implications, because they will probably take different type of logs, and they will interact with different other type of log modes, which we will see what they are. So there are like this is the list that, I took from the Postgres documentation, and I kind of color-coded them. The way that you go from top to bottom, let's get stronger. So the lighter ones are not for DDLs usually. The operations that are kind of purple marked, they are like DDL logs, and they are stronger. The more you go down, the more stronger it gets. The first one is the most basic one, used by select operations. So you can, multiple transactions can hold this simultaneously. It is the least restrictive. And then we go down, there's row share. It's for like select for update and share blocking. It's mostly compatible with everything, almost, except the exclusive logs. And then there's DML operations like updates, inserts, merge, that those are taking row exclusives. And then you go down, there is share update. That's for like maintenance operations, like, I don't know, vacuum analyze, create index concurrently, and so on. And it conflicts with pretty much all the below. And then you go down, and then the one that we are trying to avoid most is obviously the most restrictive one, the access exclusive. So it can be by operations like drop table, truncate. You really need to take this log to do these operations. And vacuum full is the most restrictive, and it will block all the concurrent access to be able to do this schema modification. So that means downtime usually, and that's why we are trying to focus on this specific log. Okay, so finding which operation takes what log, it's relatively simple, because you can actually go to the documentation or just run it beforehand to see what kind of log it takes. But how they are interacting, it can get complicated. There is another matrix in Postgres documentation, shows what type of logs kind of interacts with each other. So I recommend you to check that as well. It's important to understand, I think. And a few things to remember from this table log modes, that access exclusive conflicts is everything. So that means with everything, like with selects too, as we said. And Postgres is not stupid, basically. It has lots of optimizations for DDL, especially. If it can take a weaker log, it will take the weaker log. But it's like, nothing is perfect. So there are sometimes you have to take the stronger logs. And another crucial thing, I think, is that once a transaction takes a stronger log, it will keep it until the statement has finished. So whatever you put in that transaction, if the transaction holds, let's say, access exclusive, while you finish this transaction, it will hold it for everything. So that's why it will bring me to next takeaway. Please do not mix the comments that are DDL and DML or the others, for example. If you do a table alteration and table modification, if you put this together while you do this modification, you could actually, let's say, take a row access level, like, you know, something that for DML stake that is not access exclusive, you could actually benefit from separating them. Because if you put them together and mix them, you will just hold needlessly access exclusive. So just don't mix these comments, keep them in the different transactions, and remember that if once it takes it, it will be just holding it for needlessly for the whole duration of the transaction. And the log queue, how does it work? So let's say we have a transaction, it is trying to acquire a log that is conflicting with another log that's already held by another transaction. In this case, this one that is trying to acquire this log will enter a queue behind this one. And then they will just go behind each other until this one is actually released. So then the one that is behind it will take that, acquire that log and do its thing, and the ones that behind it, it will just wait for each of them until to finish. The catch is that by default, this requesting transaction will wait indefinitely until this log becomes available. So if you don't set anything like log timeout, we will just indefinitely wait for it. It will instead, we will probably not serve anything. And that's why I think the first thing is like comes here, like making sure that you have a log timeout set. So that means that after that, it will just like fail, and then you will actually know what happened instead of waiting forever until this one is finishing. This is kind of hard, unfortunately, because this queue of the logs is not very visible from the PG log system view. You have to check PG blocking PIDs function to identify which backend is actually blocking which specific backend. But yes, that's like what I wanted to mainly say is like it will bring us to the second takeaway is just please set log timeout. Do not set it in the PostgreSQL for everything because then all the sessions will be affected, but at least sets for the DDL operations that you will do because you have pretty much control over DDL, not like applications rarely do DDLs through applications. So you have either a backend that you control, and you know when actually you will do the DDLs most of the time. So if you get a timeout, you have to also think about a retry logic, how to handle this errors that you will get from this timeouts, potential timeouts gracefully. So it's important to set this, but probably if you just set it for DDLs, you are pretty much covered. And you need to think about the mechanisms that you will have to set, what will happen if you just get a timeout from database because of this. Again, the locking queue example that I gave theoretically a bit, so I wanted to also put a simple example. Let's imagine we have a very long-running select query, and it's normally, I think it's hard for people to grasp that like innocent select can cause a lot of issues, but it can during the schema modifications. So let's say there's a select running, and I want to run alter table detach partition, which I actually chose this specifically because I was responsible from on call for S1 tickets one time, and it was the biggest payment, one of the biggest payment systems. Their automation tooling forgot to concurrently to the dashboard partition and took everything down. So I know that this is like a strange command to pick, but it's important. So let's say we are running trying to get the detach partition, and it also needs to have an access exclusive log. But since it conflicts with anything, it conflicts with the selects access share log. And then so it waits, it goes to the queue, and then I'm trying to run, let's say, simple primary lookups, 30, 40 of whatever, and they all come behind this as well. So while these are all waiting, basically all access to the given table is now queued, and no processing is happening until first this select finishes, and then alter finishes, and then the other ones will come afterwards. That's why this cumulating waiting is a big problem. It can significantly impact the performance, and especially if you have this high concurrency environment. So that's why please do not forget to use log timeout. And you have to have this failures gracefully handled, so either rollback or retry logic needs to be implemented for the DDL that will time out. Okay, so another takeaway, basically, any query, even like simple innocent selects, can cause issues during the schema changes. So monitor your system before you run schema modifications to see there's nothing happening that will actually put you in a bad position. And so far we talked like this can go wrong, this can go wrong. I wanted to actually also talk about like what we can do, what else we can do. So there are like some less impactful ways to do something, right? If you are running a schema change or a maintenance task, you need to minimize locking, which we understood, because we don't want to degrade the performance, right? And so, but what we know is that not all operations are requiring the same level of locking, which is a benefit for us. So we can think about techniques, how we can minimize this locking impact. And first thing is really simple advice is like to using concurrently. If there is a statement that has the concurrent subcommand that you could use, try to use that. For example, if you are running create index, you can probably run it with concurrently, or I don't know, for the detach partition, you can use the concurrently to avoid stuff. But none of this, of course, things come without a cost, because if you can run this concurrently, please try to run it, but then you need to treat them with care, because they will take longer to complete, probably, and they are non-transactional, which is not so ideal, so they can't be in a transaction block, which means that they can't be rolled back. And if there's a failure, you will have to handle it a bit, because they might leave partial changes. But there are commands like, for example, finalize in this detach partition that you can clean up and finish the work. You just need to be mindful and monitor what's happening, because actually internally, let's say when we don't do the concurrently, what happens in the detach partition one? The main table, that partition table, will take access exclusive log, which means that everything is blocked, you can't do anything while the partition is being detached. And the partition table itself will also get access exclusive log, so you can't do anything. You can't read it, you can't modify it while this detachment is happening. If you choose the concurrently version of this for detachment, Postgres has like 2 transactions internally to minimize it. So first transaction in the partitioned main table, it will take a share update exclusive log, which is much better than an access exclusive because you are actually allowing to read. Of course, it will still block the schema changes. You can't really add or remove columns or alter the partition or something, but it is much better. And then in the same way, in the same first transaction, the detached table will take also the same thing. So it will do share update exclusive. It will be the similar behavior. It will block schema changes, but it will actually allow operations and reads. And then while this first transaction finishes, Postgres will mark it as like it's undergoing a detachment. And then it will wait for the other sessions to finish for the table that other sessions that are using this table to finish. And then it will start the second transaction. That's why it's taking longer as well, as we said. And then this time, main table, again, will not be impacted because it will still take share update exclusive. So you will actually still continue to serve. And the partition itself has to take access exclusive at one point, but it will be much shorter than if we did it without concurrently. It will just take short one, and it will make sure that there is nothing happening while this detachment completes. And then it adds a check constraint internally. But it is much smarter, it takes longer, and if something is kind of in this one of this process failure happens, you can actually run finalize and finish this totally, so you are safe. But yeah, you need to monitor them. Again, another example, some actions we can actually split. So that's one of the other good techniques to reduce it. So you need to break down the basic large operations, if you can, to smaller and less blocking steps. So I have this one example here to have a not null column with a default value, which is a volatile function here, as I chose. So this way, if I run this command, I will block all concurrent access, so no selects. I will hold the log for the entire duration of the table rewrite, which we will do, and it might take, I don't know, minutes or hours, depending on how large the table is. So it is really single and heavy operation, which we are trying to now break into 3 steps. So instead of like running this, what I do, first, I'm adding a nullable column with a default. And then I'm going and updating, populating any null value. So I'm running this update. And ideally, you should do this in batches. You don't want to run, remember, long-running queries. We don't want them. So make sure that you separate them in batches. And then I go and I add the null later. So why do I do that? The first one, the initial column addition without this default value that I have, is really brief access exclusive, so it will be very short. And then when I do data population one, I'm not using any more access exclusive, I'm using row exclusive, and I'm allowing the concurrent operations to happen. And then if anything goes wrong, I can just roll back, it's normal. And then basically I can reduce the log contention just by separating them. And of course, please keep an eye on whenever you do these operations, keep an eye on your system. And then, but I think we can do further optimize here. Remember, this is the last step that we had in the first command here. We had the set not null, and that was the end of it. So this is an improvement, but it will still take a long time. It will still block the writes. It will not block the reads as if we were doing it the first way, but we can just make sure that we can improve this, even though it's an improvement, because normally this will be longer, this version is shorter, and it only does one table scan, so it's much better than the first example that I give. But there are ways that we can further basically split this up. Here I will leverage something called check constraints in Postgres, and I'm adding the first one as like not valid. The way that I add not valid is important here. And then I kind of go on and I validate the constraint later in another step. And this validation step doesn't actually block writes. That's why I choose that way. And then afterwards, if you want to do the set not null again, you can just add this as how we added at the beginning. But this time, Postgres is smart. It understands that there's a valid constraint here now, so it will be very short. So it will have this access exclusive, but it will be a very brief one. And then, of course, you should drop the now redundant check constraint that we added and then continue. But of course, when you drop the check constraint, there will be also another brief access exclusive, but it's still much better. Why? The way that when we add the not valid check constraint, it only cares about the new data that you will enter. So it doesn't care about the existing data validation. And then once I do validation, this time I also only just validate the existing data. And then I will just continue, make the not null later on as a constraint, and I'm done with it. So it's really, I think, smart way of handling it. It's a known technique, it's not something new, but that's how we were doing it before we had the smarter tools that I will describe when I was working as a DBA. Okay, so that's the takeaway, basically. It takes expertise, but it's all documented. Nothing is new, so you can actually use these techniques to minimize locking. And another good news, of course, I need to do a bit of Postgres advocacy here as well. It keeps getting better, and it has actually lots of optimizations when it comes to DDLs, and it improves with each release. Each release introduces new concurrently commands, and things that are problematic in one version wouldn't be anymore maybe problematic for you. So if you can upgrade to the latest version. I chose this example on purpose because in older versions of Postgres, if I'm just trying to do default 1, for example, it would still trigger the full table rewrite, but not anymore. In modern versions, it executes very quickly because Postgres sees that there's a constant value. So I can store it as metadata. I don't need to rewrite the whole table. So now it's very minimal duration of locking, and it means that it's not disruptive anymore for production. And yeah, so if you can upgrade your Postgres, and yeah, lock mechanisms itself is being improved, and long-running things might not be anymore long-running. It can become like this metadata only changes, as we've seen in the previous example. And then we have this tool that I want to introduce. This is an open source tool, so you can try it out, and we don't have any other features kind of hiding behind our platform. So whatever we have there in our platform is also available open source. There are lots of schema management tools, I think, and most of them are probably integrating with whatever environment that you are using with ORMs. I think maybe one separation point for PG role is that it's specific to Postgres, so all the things that I talked is already implemented in the tool, and if you're a Postgres user, it might probably be useful for you. And there are also paid, like, enterprise solutions. And what I noticed when I was researching that most of them treat rollbacks as a big problem, and they're always the paid features. So if you want to do easy rollbacks, we can just do it here easily. So the motivation, I think the motivation is this talk. Like, we could see that some Postgres changes are difficult, and ideally make it less difficult was one of the motivations of why we built this tool. And there are a few things that I want to mention about the tool. One of them is like multiple schema versions. So we have like 2 versions of the schema active at the same time of the migration. So we have the old schema that you didn't do the changes, and the one that you are trying to migrate to. And it means that both of the versions of the applications can coexist, so you can do blue-green type of deployments. And once you are done, you just migrate to the new version and then test everything before you finish migration. And then if you are not happy, you can roll back, drop everything that you created, and continue. So that's one thing that is beneficial. You don't really need to do your migrations this way, but people like to do it roll out gracefully, so you can. And we are trying to basically implement all the things that we talk in the talk to the tool. So we are carefully splitting the transactions. There is like this log timeout edit for the DDLs. You can arrange the batch size and batch delays and so on. So it's already easy. And yeah, rollbacks are easy. So you can have actually 2 versions, as I said. Then you can just roll back. So you can remove the new schema version that you created. And then you can actually keep old version intact throughout all this migration. So you can just continue to work without any disruption. And we also do data backfilling. I think it's also important to synchronize the data. So we synchronize data between new and old versions with triggers. So if you have the new version entering, let's say, you are introducing not null, you can still, old version can bring, let's say, null values. And we are transforming them the way that you wrote in a up or down trigger, so that we allow null still from the old one, but we don't allow in the new one. And if new one is entering any new data, we are just pushing it to the down as well. Okay, so I actually explained, I think, how it works roughly. But instead of writing SQL migrations, the default is YAML migrations and JSON. This is kind of frowned upon in Postgres community because everybody likes to write SQL, which I understand. I like SQL more than these other languages. I mean, YAML I have a bit of more love than JSON, but anyway, so we allow these high-level operations, and it is using something called expand and contract software pattern, which I didn't know before. Which basically is that you keep adding stuff while you do the migration, So in this case, let's say you are adding a column or constraint, you just keep adding stuff without touching the old stuff. And then you allow the testing. And then once you are done, you just reduce the thing. So if you are switching to the new version, you remove whatever you created for the old version. And then you just keep one thing. So you are first expanding and then contracting. Okay, so I said like, this is how you can change a column type. The example that I put here, you just declare what is the table that you are doing the alteration, what column you are changing, and what type you are changing, let's say. And then you have this triggers, like up and down triggers to do this casting. And yeah, you can do this in JSON or YAML. It's more convenient for the developer-oriented people. I feel it's more easy for them. But yeah, not everybody is directly happy with writing the migrations this way. For them, if you like to write SQL, there's a SQL way of doing things. You can just write your SQL. But to be able to benefit from this multi-schema version stuff, you have to use these operations this way. Again, I think I mentioned this sufficiently for the expanded contract. We just like adding this temporary columns to the physical table. We are backfilling the data, transforming in the background, and then we have these views, different views. So each version of the application see the one version of the view. So one version of the old version of the table is shown by the view that is old application is connected, and we have a new view that is in the new schema of the things. So all the applications see different view and different schema versions basically. And then once they are not needed, we are just deleting them. And there's this space that both versions live together. And you start the migration, you do the rolling upgrade, and then you either roll back to the V1 or you just continue with the V2. We have a nice blog written about this topic if you want to see how we actually do it. Multi-version schema migrations in the Zeta blog. It's a bit small, but you can find, I uploaded the presentation, so you could find it. And next. Here I wanted to also show how the different schema versions are exposed via views. Here in this example that I picked, changing the full name to first name, and then we are adding the last name, because schema is literally like, I don't think we have a schema, we start with one schema and we never change it. These are like maturing, they are changing, we have to add or remove something. So that makes this problem still valid if you want to do zero downtime. So you have to think about schemas are changing, so we have to actually find ways. In this case, we are changing it, and we are adding, I think, some not null constraint to the H column. So this is like physical schema, actually keep the full name, and then adding the new not null constraint there, and the new last name. So the old version of the view still sees exactly how it was before the migration, and the new version of the view has the new columns and the new constraint, and during the active migration, both views are available. And we just do the transformation between, and then once it is done, we just drop the old stuff and just keep the new view. And the way that how application actually selects the version is like we are utilizing something called search path in Postgres. So this is how they can connect to the schema that they are targeting. So if you are targeting the V version 0, let's say, you are having that schema, and then new schema is the one that you are migrating to, so your application can switch. And again, you can control the batch size and batch rate, which is important, I think. And you can write these constraints yourself. How do you want to do these modifications? And we do it with triggers, Postgres triggers. I think it's good because for people who do these migrations, usually it is split between database and application. The way that we handle it, we take it to the database layer. So it's like you don't end up between database and application code, but you can handle everything in the database layer. It might be beneficial for some, maybe not so good for others, but if you are handling it through database, it's good for you, I think. And as I said, if you do the log timeout, you have to handle this retry logic, and we have it already in the tool, and every alter is prefixed with the set log timeout. And the benefits is that I think if you have this problem of how to do zero downtime while you do blue-green type of deployments, that's the benefit. Rollback is easy, it's not a premium feature, and we are handling the locking issues that you probably have to think if you don't use the tooling. And yeah, merging workflow is sort of simple. And yeah, there are tools out there. This is not the only one. This is the one that I know of, but there are like lots of tools around, and some of them are open source. If there is something that can help, try it. And what I would like to ask that if you use a specific tooling, we need people to, because we try with different ORMs because people have their own environment, and everybody uses Postgres, connects Postgres differently, manage their migrations differently. So if you try anything, try with pgrole, and if it doesn't work for you, or the way that you don't like how we have the pipeline working, just let us know, create an issue, talk to us, and I will be really happy if you do that. And we keep writing blogs in Zeta. It's one of the things that we actually care. All of us take time to write blogs. And if you are not knowing, maybe not following this aggregator for blogs for Postgres, it's called Planet Postgres. We are also part of it. So all the Postgres-related companies and authors, when you write something with Postgres, usually ends up in the Planet if you register yourself to the feed. So you can just follow that or follow our blog as well. And Dankeschön. Thank you for coming. And yes, I use LinkedIn. Today somebody taught me how to create the QR. And I was always going to Profile, but it is not from Profile. You go to the search and they give you this QR code from LinkedIn. So thank you.
Are there any questions in the audience or in chat? Okay, then I'm just going to pretend. Thank you for the talk. Are there any new features you will implement soon in the PGO?
Yes, so we are really working with this more ORMs that we are testing it. I recently heard somebody saying SQLRC or SQLC. They still keep writing the migrations in SQL, but they feel like they would benefit from the locking issues, because most ORMs, they create when you write this operation, they generate SQL, but they don't really care about locking or dividing the things. And some of them have the optimizations and a bit more smart, let's say, but not really all of them. And specifically focusing on Postgres is something niche, I think. So we are trying to test because some of our customers are using this tool and that tool. So that's one thing that we are focusing. And one other thing is that I think some people use this search bed differently in their applications. So they are not really happy that we are actually forcing them to use it. So we are thinking of ways how we can maybe not make this as a requirement and find other ways. So we are researching about it. There's another thing is we are kind of tied to views, right? So we just preserve this state basically, and people can connect to views. So again, we are researching about ways that making us kind of not strongly dependent to views. So that's something also currently being in research, let's say. And yeah, we are checking the user feedback. We have a Discord, Zeta Discord, and specific to pgrole as well. We have GitHub discussions for pgrole. And I am managing other projects as well in Zeta. There's one called pgstream for CDC tooling if you need it. That's also open source. We are building agents and so on. So there are a lot of open source things, and I'm mainly focused on the open source platforms and open source tooling. So check out and let me know if there's anything that you'd like to see in the tool. And in general for Postgres too, because I collect for Postgres feedback because I'm in every table. So I'm like, if I hear something with Postgres, people are struggling, I just always take this feedback in general for Postgres as well. So thank you. It's a late session. Thank you for coming. I'm happy that you were here. Thanks.